Hello, Professor Frank Armstrong from Ferris State University. What we're doing here today is we're going to try to provide you with some examples of how to do the formulas that you learned in Management 370 so that when you come out of the classroom and go back to your room or go home and try to work the problem, you'll have something to work from. So, the first thing we're going to start with is the capability of the product or the process. CPK is very important. CPK stands for the process capability. And the way you figure that out is you have to know what your tolerances are. By the way, tolerances and spec limits are interchangeable. For instance, a product that the customer orders at 1.250 has a tolerance or spec limit of 0.005. So that means that this product could be anywhere from 1.245 to 1.255. And as long as that product was in that range, it's an acceptable product to the customer. So what we want to find out by a capability index is to find out how capable is the process to make parts in that range. A standard deviation, as we talked about, is the standard deviation between one measurement and the other over a group of measurements. So if you measured 100 parts and you added it all up and divided it by the number of parts and found out what the deviation was between all those parts, the standard deviation in this case, for the example we're using out of the textbook, is 0.0083. And after adding up all the parts, measuring them and dividing by 100, let's say, because that's the sample size we used, we found out that X bar, or the average mean value of the part, is 1.251. So we have all the numbers we need now to figure out the capability index. We know what the tolerance or the spec limits are, we know what the standard deviation is, and we know what the average mean value is of the parts that were measured. So we take a look at our formula. CPK is the minimum of either X bar, which is right there, minus the lower spec limit, which in this case, the lower spec limit would be 1.245, divided by 3 times sigma, or 3 times that number, the standard deviation number. Or the upper spec limit, which would be 1.255, minus the X bar, 1251, divided by 3 times the sigma, or standard deviation again. So when you do the math, you'll see that we have the X bar, 1.251, minus the lower spec limit, which is 1.245, divided by 3 times the standard deviation, and you do the math, you get 2.4. But we need the minimum score, so you have to figure both. So you also have to look at upper spec limit, which in this case is 1255, minus the standard X bar number, which is 1.251, divided by 3 times sigma, again the same number, and you do the math and you get 1.6. So you have to choose the minimum, the lower. The reason is, again, this is the least capable, the parts that were measured, this is the least capable, and that's what you want to go by. It would be nice to choose the most, but what if you had 2.4 here, but only 1.1 here? That wouldn't be good. And again, remember, the minimum acceptable CPK is 1.33, correct? So, again, there's how you do the capability factors for the process that you're measuring on. All right, so I'm going to zoom in on that formula so you can take a look at it. And then in our next film, we're going to take a look at how to figure the run chart for the upper control and lower control limits, and we'll explain the difference there. And then in another video that we have, we're going to go over how to configure for a P-chart. So again, I'm going to zoom in here. And there you can see the numbers that you need for that formula, and I just explained how we get them. So we'll move on to the next video now.